Howdy guys, here we have our square wave with diodes example problem, which is example 2-15. And I'm going to walk you through what we have already with the circuit diagram, and then how to calculate it out, and what's actually happening conceptually. So, here we have our voltage source. Our voltage source starts with a positive there and a minus there. So positive's coming out to begin. And the voltage source is Vs of t, which means this voltage source is going to change. And that's why I also drew it in blue, so that we can look and remember what that change means. Over here we have our first diode, and then we have our second diode. This one, if this is positive up here, this means this is forward biased. If this is positive up here like it says, that means this is reverse bias. Then we also have two resistors, a 53 ohm in series with that diode and a 106 ohm in series with that diode. So what this is saying, if this is positive up here, because this is forward bias, some of the current is going to flow through here. All of the current actually, because this one is reverse biased, nothing can go in the opposite direction of the diode. So that means zero is going to come through here. That's only if this is positive though. How this problem actually goes is, if we look, we're going to draw a nice little current versus time plot here. So this up here is going to be voltage of S to time. So this is the voltage with respect to time, and then of course this is time. In seconds. Let's just put it there. That makes it nice and easy. So what we're saying with this waveform, and this is given in the problem, is this waveform is going to be 0 at here, all the way before any given time. So this is when we plug the circuit in, because when before the circuit's plugged in, nothing's working, so 0 voltage. And now we plug the circuit in, and from 0 to 1 second, we're going to put that as 1, this is going to be 6 volts. So that's the first bit coming out. So 6 volts from 0 to 1 second, so that's going to come up. Now the square wave means that we also have either a negative or we have a dip down, which is going to happen here. This is actually going to go through, and this is going to go minus 6 volts up until 2. So this is going to be 1 second, this is going to be 2, and then we're going to keep it 0 after that. Okay? So, wow, what is this saying? We have minus 6 and positive 6. Yes, you can have negative voltage. What does that mean? That means that this positive sign and minus sign are going to flip for the second part. So this is actually 3 different circuits, the way we're looking at it, at different points in time. Before we start plugging it in, it's just going to be a power supply sitting there. Nothing is happening. Nothing is going through. From 0 seconds to 1 second, we're going to have 6 volts. So if 6 volts is coming through, that means this is positive up here. That means all the current is flowing in here and nothing is happening. So this is from 0 to 1. This is an open circuit over here. Nothing is happening. And now we also have from 1 to 2 seconds. From 1 to 2 seconds, that means the positive is down here, that this power supply flips. And because this is positive, now this piece doesn't count, so we're going to get rid of that. And from 1 to 2 seconds, this is the only circuit that we have, going like this, in that direction. So this waveform is going to do 2 things. If these are LEDs coming out, let's make these LEDs just for kicks. There we go, there we go, there we go, and generally we do a circle around it, and then a circle around it. So see, now we've made these into LEDs, so diodes that emit light instead of just heat. These are going to blink back and forth every second. So this is 0, 1, and then 1, 2. So this one's going to be on first, and then this one, and then this one, and they're going to go back and forth and blink from 0 to 1, 0 to 1, 0 seconds to 1. Now, interestingly, let's just say that these are the exact same LEDs, which actually, because of the forward voltage, 0.7V, they probably are the exact same LEDs, the same diodes. So what's going to happen between the blinking because of these resistors? So conceptually, let's think about it. If there is more resistance in front of this LED and less resistance in front of this LED, that means there's more there's going to be more of a voltage or current available, or more voltage going this way. There's more current because there's an easier path for it. And that's going to mean that this LED is going to glow brighter than this LED, as long as they're tuned properly. So it's going to blink back and forth, but this one's going to be super bright and this is going to be dim. Bright, dim, bright, dim, bright, dim. And that's what this circuit is essentially doing based on this waveform. So now let's kind of calculate out to be able to see some of what's going on a little bit more. We want to know more details here. We want to know more about the waveforms. We want to know more about the current going through different pieces of it. So what we're going to solve first, we're going to be able to start to solve some of these and generate plots for the current of 1 versus t and the current of 2. Because remember, this is a plot of voltage versus time. We're going to want a plot, I'm going to do that right here real fast, of current versus time. And this is going to be time in seconds again. Because as this goes, the current is going to change because there's less resistance here and there's more resistance here. And so that means the current being delivered to this circuit is going to be different depending on which direction it goes. If this is positive up here or if this is positive down here. And so what we're going to do for this is we're going to be able to solve through. So I of t equals VA minus 0.7 divided by R1. How did we get this? V equals IR. If the R is up here, that means the V is going to be equal to VA minus 0.7. 0.7 is coming from the forward voltage. VA, if you look in the book, is going to come from here. And we're going to draw a ground system in there. So that just to tell us where our ground is. Doesn't matter, it could be anywhere on that line. So VA is just what we're going to call this node. So how do we solve for this? From 0 to 1, we're essentially cropping out that part of the circuit, and we're just solving it as it is with Kirchhoff's voltage law. The sum of the voltages going around the loop equals 0, and that's what we're doing here. And so when we plug this in, we're going to plug in 6 minus 0.7 divided by 53 ohms equals 0.1 amps. And this, remember, is only for 0 to 1. So this is for time 0 is less than equal to time is less than equal to 1. Because remember, once we get to 1, it switches, and then we get rid of this part of the circuit. So we've solved for just this half of the circuit right now. That's where we leave it. Let's do I of t going in the other direction. So we're going to call this I1, and this is going to be I2. And this is going to be equal to what? Well, we're going to go in the other direction. So if we get rid of this, we're going to do the exact same thing in the backwards direction, because now the positive's here, so it's going to flow through, and this one's going to be ignored. So we're going to get I2t equals 6 minus 0.7 divided by 106, because remember the resistance changes. And that's going to be equal to 0.05 amps. And again, this is from a different time. This is from 1 is less than equal to time is less than equal to 2. Now finally we have one other time constant from 0. So anything before 0, so minus infinity to 0, we're going to presume that this circuit isn't even plugged in. There's nothing coming out before that. So anything before 0 is going to be 0 in the current. So we can do from minus infinity of time, t is less than equal to 0, which is kind of self-explanatory. But essentially that's saying that anything before the circuit is turned on. So let's draw this out. First off, let's draw what's happening with this current with respect to time. Let's start with this one actually. Before we turn the circuit on, we have 0 current coming through. 0 current coming through before we turn the circuit on. And now we're going to look at if the circuit is between 0 and 1 second, so this is 0 seconds, this is 1 second, this is 2 seconds. So between these two, we're going to have, between 0 and 1, we're going to have 0.1 amps. So this is going to be 0.1 amps. So we're going to have a bar across. So we're going to connect that bar and connect that bar. And then what happens after 0.1? After time equals 1? Well, after time equals 1, no current is flowing through this. So we're going to get 0. Because remember, after time equals 1, this flips to a positive here. And positive can't flow backwards through this. So that equals 0. So now what's going to happen with, I'm going to box that just so we know where that color came from. And now we're going to do the other part of it too. So what happens from 1 to 2 seconds? So from 1 to 2 seconds, we have 0.05 amps. So nothing is going to happen before 1, because remember, before 1 second, from 0 to 1, all the current is going in this direction. Nothing is coming backwards through that diode. So this is going to be 0. And of course it's going to be 0 here too, because the circuit's not plugged in. And now from 1 to 2, we're going to have 0.05 amps. So 0.05 is half of that. And so from 0 to 2, we're going to have it look like that. And then of course it's going to go down again. And we're going to have down. So that's what the plot looks like of current versus time for these two. That's kind of a cool problem. I like that. So let's just recap then. New pieces of this one, square wave. Instead of just having a constant power supply, we gave it a power supply that changes. And we call this a square wave because it approximates a square, and it's a really nice mathematical way of calculating it out. Because it's a square wave, that means a positive and negative switch, because you have a negative voltage here, which means this whole power supply switches around. When this switches around, no power can come up through this. When this is in the first position, power can come down through this, but nothing can come up through here. So that cuts that part off. And that's why we get these two different currents. Two different currents also come from the different resistances. So if these were both 53 ohm resistors, it would look, this one would be at the exact same level as this one coming out. They would both be the same level. So that's what I want to do with that one. If you have any questions, feel free to ask.